Hello, thank you for visiting. In this lecture, I'm going to talk about calculations like how do you size the heat pump and how do you size a solar hot water heating system. Now, mind you, I'm not using a lot of very fancy measuring equipment, engineering equipment. It's just something that any homeowner could do. And so I'm just going to coach you through. I'm using my apartment complex as an example. So what I'm doing here is I'm looking at how big of a solar hot water heating system I can use and how much heat pumps. And I'm going to talk about other things that you can do to make the house more energy efficient. Continue here. I took my bills and I looked at how many kilowatts I was using for each month. I don't have natural gas, so only thing, this is an all electric unit. So my highest was 6,000, about 6 million BTUs per month. My lowest was about 1 million or about 2 million BTUs per month, which gives me a range. You know, wintertime you tend to use more electricity because you got electric heating. So that just gave me a few ideas of where I'm looking at. To convert kilowatt hours to BTUs, let me put it this way. For every kilowatt out there, there's about 3,000 BTUs. BTUs is a measurement of heat, and kilowatts is more of a measurement of electricity. So here I got through, and I looked at how much how much energy is used by my furnace. And by looking at the differential between the highest and lowest, I decided that 29.5% of the heat is used by my furnace to keep the unit warm, in the unit, or about 30%. So it just gives you an idea of how you can take your electric bill and come up with the idea how much electricity is being used to heat the place in the wintertime. And I looked at my circuit breaker. And I calculated how many kilowatts I'm using, and then I converted it to kilowatt hour, to BTUs, from kilowatt hours to BTUs. For my main, which is the whole house, my house is rated at 22 kilowatt hours, which is huge. The furnace was 74, the range was 37, and then I had central vacuum, lights, dryer, hot water heater was big, kitchen plugs was big, disposal and lights. Basically, the furnace is the biggest unit, the hot water tank is the biggest unit, and the reason why they do kitchen plugs is because they got a lot of things people plug in that consume a lot of electricity. Each unit here consumes 22 kilowatts hours, and let's put it this way. The electric utility is kind of concerned that we might melt the power line, so consequently there's a talk about trying to put in heat pumps and solar hot water heating systems. There are things that can be done. If we install a heat pump, we can take the existing furnace and make it into a blower only, install a ceiling fan since I have a double-decker unit, and that way I can blow hot air downstairs and cold air upstairs. Install a storm door. You can also do this to windows, but a storm door would save a lot of heat going out through the front door. And then something else too, your appliances and your stove and your washing machines adds a little bit of heat to the building. Things I'm doing is calculating the surface area. I need to know how much surface area I have for my windows, surface areas for the wall, surface area for the roof, and surface areas for the floor. That gives me, and then I do a rough calculation as to how much heat's going through the walls. It's called the R value. So what I did is I calculated what would happen if I added a solar window greenhouse to all the windows, and it gave me a 32% efficiency. Basically, I'm putting a little greenhouse to grow plants on each one of the windows. It also adds an extra layer of glass. And so then I made a worst case analysis as to how much heat would be lost through it. I assumed that the worst case analysis would be negative 20 degrees in the winter, and that's like a really bad winter storm. I took an idea of guess how much hot water heating, 60 gallons per day, 120 gallons per day, and then I calculated what the solar potential was. There are evacuated tubes. Each one is rated 1,000 BTUs per day, and then also I'm also using some of the hot water to heat the house. So this gave me an idea of how much demand I need for hot water from a solar hot water heating system. And just on the basis, I just a big guess, I figure the house weighs at 300,000 pounds or so. So one of the things I want to do is convert the greenhouse windows, and so I went through and calculated how much heat would be conserved if I was to convert the windows to be solar greenhouses. And this is a bill of materials. And basically it's really simple to do. A good carpenter can do this. You basically take recycled windows, put it in there, frame it, and that way you are able to grow plants in your window. Outside that can be done is solar lighting, and you can put and also a windmill that will do lighting. This is actually, windmills tend to be more light in the winter time, and solar tends more light in the summer. And so it's a little sketch of what it could look like. And then a solar powered ceiling fan, the attic fan to keep the place from, let's say, keep the roof from. And then things you can do for fire prevention. Every energy plant should have fire prevention integrated. Electric vehicle plug-in. You can put in just a regular plug outside, wired directly to the electric circuit breaker box, and then you can have 1 kilowatt. That'll be a trickle charge. And so after you've done all these calculations, now you size the solar hot water heat. As it ends up, I have close to 100,000 to 200,000 BTUs potential on my roof, and then you use the solar panels, solar PV panels for the pump. And then I route it through the wall, not through the roof. That way it keeps me from preventing. And then I route the pipes along the edge of the walls to the solar hot water heating system, and then out the back. And then I have a hydro air hot air system which can heat the back room. And then I add thermal storage and a couple of pumps to route the heat transfer fluid through a gravel bed. That way I have to worry about it. Now, one thing about solar hot water heating, you got to make sure it doesn't boil. So there's an overheat pump. Night sky radiation to cool down in case it ends up being too hot. You don't want to boil the water. Night sky radiation, you mean you operate the pumps at nighttime, radiating heat to outer space. That way you don't boil the water. You got to be maintenance for the heat transfer fluid and that thing. Now, one of the things that you can do to finance it, you can form your own micro utility. I call it a solar wind micro public utility. That way you can finance it for like an apartment or several apartments. So with that, what I see here is potential of 200,000 BTUs per day for the solar heating system. But let me point out too, you're going to have to run this past a professional engineer. But you know, any heat pump installer and can run these calculations for you. With those comments, I say thank you for considering solar power in your home. May you have a nice day.